some of you long-standing members may know that we are Third Republic, and we founded this a year and a half or so ago. And the idea is to kind of give back to the DevOps and SRE network from other like-minded individuals and kind of share experiences and advice with their peers, and ultimately just gain a bit more knowledge and more within the community. Meetup now's over 1,000 members across Germany. We've done them at, like Google, Smava, just to list a couple. And today we have Nikolay, who is a ex-production engineer from Facebook. And we also have Nikolay, who is the head of platforms over at HolidayCheck. Both have a fountain of knowledge and obviously some great talks lined up. Nikolay, I'll pass the floor to you.
Managing a large infrastructure and the importance of an awesome on-call. I'm trying to present this the subject here from the on-call perspective. So, having an awesome on-call, I think it's really good for your, personal health, I guess. So, agenda. Quick introduction, the main ingredient, monitoring, metrics and alarms. Then we move to configuration management and orchestration, and then design and architecture at the end, and questions and answers. So hello, my name is Nikolay, and I was a production engineer at Facebook, and I would say I have like skill set mainly which is like systems, networking and coding. Different companies name their role differently, so production engineer, site reliability engineer, and platforms or DevOps engineer. If you would answer a question, what is the most important piece of your infrastructure? I'm really curious what that would be for you, what you are thinking about. This is my main angle for this talk, right? For me, from my perspective, it's you, right? That's the most important part of your infrastructure. So I strongly believe that you need to take care of yourself, and on-call can be really like a burden. So what I'm presenting here, those approaches or tools, or what you could have in your infrastructure, or maybe you have it already. I'm looking from the perspective like having really healthy on-call, which is I think important. If you own an infrastructure, I think you should be able to very quickly answer following questions, right, about your infrastructure. Does the system work? How performant it is? How consistent is the system behavior? How fast you can modify the behavior of the system? And how safely you can roll out the modification, right? So having very clear answer for those questions, it's really helpful. I think that should be your focus, right? If you're not able to answer those questions quickly and in a clear way, that's probably a signal that something is lacking in your infrastructure and your tooling on your environment, right? Those questions are kind of grouped into sections, I would say. So first three are about like monitoring and metrics and alarms as well. The two last ones are about configuration management and orchestration. Monitoring, metrics and alarms. So does the system work, right? That was the first question. So what does it mean? Like how you can get information, does the system work? For a starter, I think if you just to have really strong signal that system doesn't work or not, like simple Boolean metric, yes or no, 1 or 0, green or red, that's a really good start, right? If you're not able to answer that simple question, does it work or not, through a metric, I think this is something which, step one, create that super simple metric. And then if you have that metric, 1 or 0, about your piece of infrastructure, then the next question would be, how performant is that piece, right? How much time the operation took? This is something which you should be able to answer as well. And if you want to answer that question, it's really good to try to answer it from the perspective of the client, right? You may have, many nodes. Maybe there is something in between those nodes and the client, like load balancers, like, some filtering, web, firewall, whatever that is. Those components in the middle between your service and the client can introduce latency, or they may introduce unpredictable behaviors. So having the performance measurement from the perspective of the client, I think it's a good approach to do that in that way. Your monitoring systems, they see what your clients see. However, this caveat, you should minimize external factors between your system and the client. So for example, if you're like, I don't know, mobile developer, you have a mobile app and your backend infrastructure is in some data center, right? Between the mobile phone and your data center, there's so many moving parts which you do not have control over. Like, someone can be on the LTE network, 3G network, they may switch to Wi-Fi, they may be on the move, like in the train, in the car. All those moving parts, they basically introduce a lot of noise to your measurements. So you should, remove those factors and maybe cheat a bit, and then monitoring the infrastructure maybe from within your data center, but as possibly as close as possible to the view of the client. The code, the network path should be kind of similar. So hit on the way the same firewalls, like web firewalls, whatever that is, like load balancers, whatever you have in your infrastructure. And then, yeah, from the performance perspective or resource management perspective, like if you have the latency, the next question about your component would be like how much memory it is using, right? That can be measured from the very close to the app, right? So practically on the host, RSS memory, how much the application is using RSS memory, or like if you have C groups, then maybe C groups memory utilization. If your application is a little bit more complicated and you would like to have more fine-grained view, what kind of where the memory is allocated, how the memory is allocated, you may extend your application to expose internal memory stats, so you can monitor them as well, right? That would be the next step if high-level view of C groups memory usage or RSS memory usage, or it's not good enough for you, right? And then the same concept on the disk space, right? How much disk space the component is using. So you may have, dedicated partition for high-level view. If that dedicated partition is fully assigned to your application, then you can quickly fetch data about disk usage. And then maybe partition is not enough, then you have to separate disk, but conceptually it is the same approach. And then again, if the data structures, like the disk usage, is more complicated, which you would like to see, in more detailed way what's going on, how the data is used, the same approach like with memory, expose internal usage stats from the app so you can graph them. And then how consistent is the system behavior, right? I'm talking about like, is the system up or down, or how fast is it, how quickly it can answer the query. But in distributed system, there is so many nodes. There can be like many different nodes. There can be load balancers. They can be, the infrastructure, the system can be unicasted. So it's like everywhere you go to the closest one. You may have a mesh setup, so everyone is talking to everyone. In that scenario, it's really difficult to answer, what is up or what is down. You may have like 9 nodes up and 1 is down. The system is not really down, but it's not fully up either, right? So you may have, if there is an issue, you may not have a consistent view and signal about the failure conditions, right? You may have elevated latency once in a while, right? So, most of the queries are good, but sometimes there is a spike. And this basically boils down to distributed environment and like many nodes doing the same or similar operations. So to understand your infrastructure and to quickly troubleshoot where is the source of the problem, you should have appropriate tooling, right? To figure out which metric is the one which is not within the thresholds, and that's the sort, that's indication of that can be a problem. This, you need to look into that direction because that metric is not right. And the tooling is extremely important, and access to the collected metrics, right? This is probably not that big issue, depends on the company, but I've noticed that when I was speaking with different companies, sometimes they are really segmented. Different business units, they have their own kind of mini infrastructures, and people don't have access to each other's metric or other systems because of compliance reasons or whatever the reasons are. I think you should avoid that as much as possible. Like something like metrics and troubleshooting should be open for everyone, so they can, people depend on each other's systems. Someone is, using DNS, the other people are using MySQL or, whatever other system. And I think giving everyone access to the metrics, it's super important to help, troubleshoot the problem as not one team or one person, but as an organization as a whole, right? So yeah, just to sum up the metrics, like I would like to stress that metrics for the awesome on call are extremely, extremely important. Like collect as much as possible. Collect metrics from the single nodes, collect aggregated metrics from in front of the load balancer, right? If your system is more complicated and like there's many stages of your environment, collect metrics from all the stages, right? Anything which can be measured, measure it. Which can be contributor to the like user experience at the end, how the query was served. Was it fast enough? Did you get HTTP 500, HTTP 400 by some mistake, or does the system work, right? So collect as much as possible. And if you don't have a lot of metrics, like starting with something extremely simple, 1 or 0, it works or it doesn't, I think this is really good start. Like it's super simple, and yeah, like if you don't have a lot of metrics and you lack a lot of metrics in many places in your infrastructure, start with something simple. And then over time, you expand your metrics, right, with more advanced details like, time or latency or like CPU usage or memory usage or storage usage or, whatever else which is indicator for more granular signal, what can happen in your infrastructure. Iterate on top of it, right? Grow your metrics bigger and bigger with more details. Yeah, and as I said, many vantage points. So yeah, from different places, I mean like, single nodes, aggregated nodes. So yeah, aggregate data. P50, P95, P99, different dimensions like, what's the CPU usage across all web servers? What's the CPU usage across all MySQL servers? What will be the CPU usage across like, all DNS servers, right? Or what will be the memory usage this is not good correlation maybe, but if you have an outage, like the power outage, for example, if you collect uptime as a metric, uptime of the server, you can, graph aggregated uptime metric on different rows. And if you see like, pattern change in the graph, maybe there was like a power outage within one full row, and it's very easy to figure it out when you have aggregated that data on different dimensions. You would like to see like, I don't know, uptime in particular region, like all servers in Netherlands, right? Maybe there was a power outage in a data center. So yeah, that data aggregation, that's something, metric aggregation, that's something which is extremely helpful to understand the patterns, right? You may have like different memory usage pattern, maybe you upgraded your operating system base OS across all machines and you see different memory pattern and you don't know, is this related to that OS upgrade? But if you, for example, draw the metrics per like, MySQL, front-end server, and then like DNS server, like, console server, whatever that is, right? You may see patterns that like one particular application changed the behavior and it's actually not related to the OS upgrade. So aggregation is really important. And if you have a lot of metrics, because like I'm trying to really stress that for really good on-call experience, many metrics is super good, but it may be overwhelming, right? You have so many metrics that you don't know even where to look. So tooling is critical. Because if you have so much data, you need to really quickly extract this data in the way you want. So tooling around the metrics is important, like dashboard, like super easy way to create a dashboard. Command line tools to extract like, data points from the metric system, and obviously alarms, right? You want to know that something is wrong. So for me, alarm is also kind of like a tool. Like the metrics are metrics, they're raw data, but you interpret them in alarms and try to act upon them like through alarms, for example. And again, unrestricted access to the metric data, right? So across the organization. So allow everyone to see the data. I think this is super important as well. But obviously you have a lot of metrics, right? Then you can define thresholds. You have thresholds, then you can define alarms. And I'm mentioning this because I've noticed that, you know, machine learning is getting so popular these days, and like everyone wants to put machine learning everywhere into the alarms as well. But I think super clear, simple like thresholds, like our DNS servers, they need to answer the query like in 5 milliseconds, let's say. And that's good enough, right? 5 milliseconds and below, it's really good. Above 5 milliseconds, you need to start looking into the problem. But you can define different thresholds, right? You may define like, let's say twice as much. Well, twice as much, actually that depends, but like, let's say 10 milliseconds for a period of 24 hours, then you look into it, right? Like, let's say 20 milliseconds of 2 hours, then you look into it. And it's about 15 milliseconds, you look into it straight away, right? So you may have different time periods. Let's say like P90 over like, you know, 2 hours, over 24 hours, over 1 week, even 1 week as well, it's good. And different values for those time periods, I think it's something good enough, right? You don't need to have machine learning to act on something like that. We have the metrics. Now the modification of the system, right? I mean, yeah, configuration management, orchestration, and automation. Second part. So infrastructure is not static, obviously, right? You need to change it. I mean, in my previous place, like I was changing it a lot, right? I mean, stuff was changing all the time. So I mean, you need to modify Nginx or OpenSSH, Postgres config, like resolve conf, something more complicated, super simple. It doesn't matter, right? Any change, to introduce any change, sometimes it's like, you know, a big effort. And yeah, the question, how much effort you need to put, you need to get to push a modification. Changes in infrastructure should be, you know, almost effortless. It should be super simple to push a change, right? You maybe modify a file in a repo, you commit, you push, and you know, in quotes, you're done, right? But more or less, it should be so straightforward. And then the next question is how fast the modification can propagate, right? Do you need to, I mean, you want to do it fast, like you want to have it rolled out in the next 15 minutes, but because the way system works, it's like, I don't know, 4 hours maybe, or even longer. So this is something which then this gives you a signal that if you cannot push modifications fast enough for your needs, like, you know, maybe 15 minutes for you, it's like, this is way too fast. Maybe for you 1 hour is okay. But for your criteria, if you feel that it's not fast enough for you, then definitely this is a signal. My on-call is not that awesome like as I would like to. So this is on you to focus on that, right? And yeah, solid configuration management is critical. You obviously want to introduce a change, but mistakes happen. So maybe you push one liner because it's, you know, it's simple change, right? It's a typo, or, you know, whatever. You bump a value from one number to another, but you may introduce a typo. And then, do you have unit tests for your infrastructure as a code? Can simple syntax, you know, error in a config file take down your system, right? If the answer is yes, you should look into it, how to avoid those simple mistakes propagating to the entire infrastructure, especially if you have like fast configuration management system. I mean fast as in the propagation goes out really, really fast. And then, can your configuration management segment or isolate a rollout change, right? If you don't have it, and you've had in the past, like, you know, you roll out a change and then it took down something which you didn't foresee an issue, then have ability to roll out, you know, let's say a change to 1% of all machine. It's super like good, because you roll it out, the change unfortunately had a mistake, but you didn't introduce a lot of, like, you know, maybe revenue drop, or, you know, whatever the metric is important for you, it didn't affect the service that much, right? So 1% of all machines, like, I don't know, 5% of all servers in Germany, 20% of all database servers, like whatever the criteria is, right? Another good tool around configuration management system is like roll out change non-interactively, like you just commit a change and you not mark it that it should be rolled out for over the next 2 weeks from that particular timestamp, right? That's something which is useful as well, right? They say you really tested the change, you know that it's safe to roll out, but because the nature of the change, it needs to be done super slowly, then something like that feature in your configuration management, it's very useful. Configuration management system is not enough, right? To have really good on-call experience, this is not good enough. So continuous integration and continuous delivery is definitely not good enough. And I'm mentioning it here because I had like, you know, after working at Facebook, I had like, you know, a couple of interviews, and many people are really focusing, like many interviews really focused on continuous integration and continuous delivery. And the main message which I got from these discussions during the interview was like they want to make it faster, right? You commit a change and it's like instantly in production, right? But the thing is, as I was saying, with configuration management system, mistakes happen, right? So you want to be super fast, but then, you know, you have an outage or like something's not working right. So I strongly believe that, you know, awesome continuous integration and continuous delivery system is really nice, but it's not good enough, like at all, for the people who are actually on call. So make sure you have a feature toggle. Like this is way more important than, you know, the way you roll out your code changes. Because I had this discussion when they want to have like continuous integration done in 50 or in delivery in 15 minutes, right? Currently it's like more than like 2 hours, but we want to, you know, but it's not optimal, so we definitely know it can be done faster, like 15 minutes would be great. But the thing is, like, your code base will grow, you have more and more, and obviously if your developers are really like taking care of the app properly, they have a lot of unit tests, and they will have even more unit tests. So making sure that every single test pass and compilation happens, it will take over more and more time when the application grows and, you know, gets more rich in terms of feature or like, you know, whatever that is. So it will get slower, and we're still talking about minutes or like, you know, like 15 minutes, half an hour maybe, right? But with feature toggle, it's seconds. You just feature rollout, which may introduce a problem. So anyway, feature toggle, super important. That makes an on-call like a breeze, right? And if you're designing new system or application, introduce feature toggle from the very beginning. Like, I mean, maybe not on the very first day, obviously, because sometimes it may be challenging, but early in the process. Like feature toggle should be very early in the process. And feature toggle is not like only application specific, right? You have it within the app. The concept can be put into any part of infrastructure, like feature toggle, A/B testing, blue-green deployment. That's kind of, for me, the same concept, but it can be applicable to infrastructure, right? You have multiple, let's say, backend systems, and like, I don't know, most of them are on Python 2. Suddenly you need to migrate to Python 3, and it's a big change, right? Python 2 to Python 3, and you don't know, will that really work the way you think it will work? You tested it on the local machine and everything is fine on maybe a few machines, but putting it in prod when you have many customers, it may be problematic. You may be, you know, you may roll out application Python 3 version of, you know, 50% of the infrastructure, and suddenly there is a problem, right? So you can build like simple, you know, blue-green deployment, like, you know, Nginx. Half of the machines are like, half of the traffic is on, you know, one version, and the other half is on the other, and you can switch between them if something is not right? And even building something more advanced, that you can switch the traffic, you know, switch the feature. Like if for every person visiting, like, I don't know, from China, you get this version, or everyone with the mobile browser, mobile browser goes to that version. Everyone on the desktop goes to this, everyone on Firefox sees something different. So this granularity, how you can, you know, navigate the traffic that kind of, feature toggle, I think it's way better than the most amazing continuous integration and continuous delivery system. That's what I've seen in the past, right? Yeah, decoupling the code push from the feature rollout. That yeah, again, super important. Orchestration can be a part of configuration management, but it's actually extremely useful and amazing as a totally independent standalone utility, right? So this is something which can trigger code after certain events or conditions, right? When they happen, like condition it can be even alarm, right? Can be really rich and complex. Yeah, that orchestration system can really introduce really rich and complex behaviors, and basically like simple, like kernel upgrade, right? That's kind of simple example. You need to drain the machine, install the kernel, reboot the machine, wait for the machine to come back up, and then do some maybe checks before undraining the machine, and then undrain the machine and put the traffic back in, right? And obviously you cannot drain all the machines at once from the pool, right? You need to maybe one by one, or maybe in batches of few machines, like every 3 machine, every 5 machine, whatever, depends how big your pool, right? And you can really with like good automation orchestration system, you can really automate everything, like a lot. And you have alarm, you can automate like action on the alarm. You don't need to log in by hand and like troubleshooting something, and then maybe you restart the service, maybe you need to trigger some code. Normally you would do it by hand. That can be automated. System can fetch the metric, see that there is outside of the threshold, and start acting on this alarm on that particular machine or entire system or whatever that is. Maintenance events, in advance that you got notification from the provider that there will be power maintenance, machines needs to be like rebooted or shut down. You can drain them, migrate the traffic to different location. All that stuff can be automated. Database migration, schema changes, storage replication, base OS upgrades, right? Like you were on, I don't know, CentOS 7, you go to CentOS 8, like Ubuntu 16 LTS to Ubuntu 18 to 20, whatever that is, right? And you have feedback loop, right? The automation is working on an upgrade or the change and constantly monitoring the metrics. That my code in that automation process is definitely affecting those metrics. I mean, it shouldn't, but it may affect those metrics. And if the metrics go outside of the threshold, the automation stops, right? Because like automating everything is awesome, except it can, create a lot of havoc in the environment when it's blindly out, doing its job, but there was some exception and suddenly everything is offline and like you have super big outage, right? So that the feedback loop, it's super important, but you need to have the metrics, right? So the metrics is super like step 1, and you can build on top of the metrics the automation. Okay, the third part, design and architecture. Right, so this is kind of tricky because it's not that tangible like previously discussed pieces of infrastructure. It's kind of invisible. I mean, you kind of see the design or maybe not. Like it's very, I think it's difficult, right? But it's fundamental. I think from all the subjects which I mentioned before, this is the most important part, right? It has the biggest impact on the entire system and on the on-call experience. So how easy is to modify parts of infrastructure, right? How easy is to extend? How easy is to scale up or down? How easy is to automate? How easy is to troubleshoot? And how easy is to bootstrap from scratch? Not many organizations think about that. Like, we need to bootstrap from scratch, but disasters happen, and sometimes it's not even disaster. Like, you need to migrate to different cloud provider, right? Because it's cheaper, or because whatever high-level decision, we need to go to bare metal and we were in the cloud, or the other way around, we were on the bare metal, we want to go to the cloud. So I've seen company migration, they migrate the infrastructure a lot in recent years, and all those interviews which I had, most of them were migrating somewhere, one direction or the other. So that's also from scratch, kind of, right? And yeah, and proper design helps you do the migration or bootstrap. There is no one-size-fits-all solution, obviously, right? I mean, But if I can give you like high-level advice for the design, try to build linear system. So one input or multiple inputs on the one side. There is a pipeline in the middle doing whatever it needs to be doing, and there is output on the other side. Conceptually, this is similar to the shell pipeline, right? You have multiple commands chained together and they do the job, right? And then together with shell, we have like Unix philosophy, like make each program do one thing, but really, really well. And it's the same with like architecture. You have many components, they do one thing, they do it super well, and you can chain them together like in a pipeline, and you collect metrics, obviously, because as I mentioned before. So on each step from each component, you have clear, well-defined metrics, and if you have an outage, because it's like, linear, you can just check every system on the way, because at the end you have an error, right? At the very end of the pipeline, or like you see, HTTP 500, let's say. But because the system is linear, you check every single component on the way, their metric of that component, and if something is not right, you know that this is the point where the system breaks. I need to look into that I need to start troubleshooting from this moment, and it will be, on the left or the right, but near that place. It's super easy to troubleshoot, and I think that's like, if something takes you too long time to troubleshoot during an outage, that's a signal something is not right? There needs to be improvement here, because it takes me too much time to troubleshoot it. It's like Lego, right? From bits and pieces you can build something really, really big, but because they're like small bricks, if that brick is not optimal, it's like crashy, like it's not that performant, you can just maybe not rewrite, but improve that Lego brick and just change just one small piece and see how the entire system behaves. Hopefully there will be an improvement. Summary: collect a lot of metrics, right? Step 1, metrics, and aggregate them. Thresholds and alarms. So this is also good, right? You can go through all the metrics, all the dashboards, look for the dashboard which has that issue, which may explain why you have, that HTTP 500 or another error. But also, if you have alarms, you will get the page, and there will be metric which is not right with the title of the alarm. Maybe you will have the documentation for that alarm, maybe not, but you will get clear signal from the alarm straight away. This is a problem. Start looking here. So thresholds and alarms, they improve on-call experience. Be able to quickly roll out changes. Yeah, obvious. Yeah. So when you roll out the changes, you need to feel confident, right? You need to have clear signal, everything is good, or actually no, there is a mistake, or there is some dependency which you didn't thought about, and like there is an issue. So segmentation of the change, right? Only maybe handpick 5 machines. You have like, I don't know, maybe 500 machines, but you pick only 500 identical machines, right? Or 500 machines which are affected by this particular change. But you handpick 5 machines and you roll it out. And you let it bake for like, I don't know, 1 hour, 2 hours, maybe even 24 hours. And then the next day you are bumping it to like 1% of all those 500 machines. And you let it bake for another 24 hours, right? So segmented rollout change. That's important. And then orchestration, yeah. To be able to orchestrate or automate any task, which can be done by human manually, right? Anything can be automated. If you have a proper design as well in place, sometimes you may say like, no, this is not possible to automate. Then figure out why, and remove that obstacle which stops you from automating that piece, that work. Design your system to help easy to understand, navigate, troubleshoot, complex infrastructure. That's something which is important. Yeah, design basically. And that's it.
Perfect. Thank you very much for that, Nikolay. I believe Jens put a question in the box.
We also try to collect as many metrics as possible, but especially in CloudWatch and AWS, what we're currently using, this can get fairly expensive if you have a lot of custom metrics, especially. And so what do I tell my manager when they complain that this gets too expensive and nobody's ever looking at those metrics, and why do we keep them anyway?
I mean, this is a very good question, because I'm really surprised people are using cloud because for me it's so expensive. Like if you have a problem that you have too many metrics and it costs you too much money, for me it's really weird place to be. But yeah, but this is a very fair question. Like this is your reality. You're in the cloud and it costs money.
Okay, this is my current situation. I don't have this question for real. It was just a thought that I had, and we have to be cost aware in the cloud, obviously. But I also had in my past, in lots of years back, when we were using Nagios, and they were using also lots of metrics. And at some point, somebody realized that, I don't know, something about 10% of our whole infrastructure was only the monitoring system. And that was too expensive, and that was completely on-premise and everything. But where's the threshold? How much is a monitoring system actually worth keeping, and at which point you have more monitoring than what you actually monitor?
To be honest, I don't know, because like the ratio where at Facebook was definitely not 10%, because that would be way too expensive. I'm trying to imagine why because 10% of the infrastructure is monitoring. That's a lot. That's definitely a lot. So I'm just wondering like where was this 10%? That sounds definitely not optimal. But where would be the perfect value? It's hard for me to say. I think it's, if you have a smaller infrastructure, this percentage will be probably higher, because if you have 5 machines and and then one of them is designed to be like monitoring, but there is no redundancy. But okay, let's say that this is one. That's a lot of 5 machines. One machine is like 20% of infrastructure is monitoring. That's like a lot, right? But if you have 5,000 machines, then having 100 for monitoring, that sounds also a lot. I'm pretty sure I can say that this is not something super secret, but if I remember correctly, we had that was 2012-ish, 13, so that was a couple of years ago. But Nagios, I don't remember how many instances we had, 5-ish, below 10, and it was 10,000 machines to monitor. But the Nagios was very simple checks, 1 and 0, up or down. There were no latency stuff, or that was just 1 or 0 metric. So we had 10,000 machines, and I think below 10 instances of Nagios. And I think that ratio is fair, right? 10,000, 10 machines. That's obviously particular metric of 1 or 0s. There is no latency information here. But the thing is, the conceptual approach was one remote monitoring, so Nagios as a remote, 1 or 0. Then resources were monitored from within the box. So basically entire infrastructure was monitoring itself, right? If you are, let's say, DNS machines, so in our case, CPU memory and usage of particular partitions where it was important. So that was monitored from within the host. So how much it costed, it's very difficult to measure, because it was just CPU cycle on the machine. So I don't know how much that was costing us, because that was from within the box. But to be honest, Nagios doing 1 or 0, Nagios could easily, Nagios or similar system could easily do latency information as well. I'm pretty sure.
It's just something that I
don't
encountered more than once so far. So I thought maybe just bring this up. So there might be a thing that is too much monitoring, especially if nobody's looking at those metrics.
Yeah, I mean, to be honest, at Facebook there were so many metrics, but when the issue happened, when the outage was there, they were amazingly important. That's the thing, how much, if you are not able to quickly troubleshoot the infrastructure, you may look into from the revenue drop perspective, how much money you lost during those 6 hours when you could troubleshoot this in 15 minutes, right? That's the trade-off here, right? But my talk is, I don't want to focus on money, because money is me as a production engineer at Facebook, I didn't see the money, right? I see my on-call experience, the pain of being responsible for this, and I need to quickly troubleshoot it. So that I was kind of selfish. I want to have an amazing on-call. That's important for me. But different part of the business, they may say like, look, we lost too much money. You need to troubleshoot this faster. And my angle here is just take care of yourself, be happy with your on-call, focus on those metrics. And to be honest, you should not look at the metrics. Like the long-term goal in our team was no one watches dashboards. Because it's like, what? You just look at the page with the graph? No, you should focus on other important stuff. There is automation. When that graph will be outside of the threshold, the automation will let you know. You will get a phone call, you will get SMS, you will get email, you will get push notification. Hey, now stop working on this super important stuff because there is an alarm. So it's so what that no one is watching them. Automation should watch all those metrics.
So do you use metrics to continuous deployment every commit?
So in terms of continuous integration, do you use the metrics to continuous return very low access to your application, could deploy a package if everything is okay? Yeah, this is definitely that approach is exactly what is on my mind. You have a lot of metrics, and that metrics they can be a feedback loop to the continuous integration, continuous deployment, to push package forward or like stop the push and basically notify on call. Or hopefully I'm answering this question, but yes, that approach is definitely something which I have on my mind. I can also add to the because you wrote every commit, and sometimes if you have big organization and so many engineers, like every commit may be not possible, so you bunch them every few, I guess, but it depends on the size of the organization. If there's so many commits because of so many engineers, then every commit is not that possible, but approach is, correct.
Nikolay, thank you very much for the talk. Nikolay, if you would like to step up, share your screen, we can go from there.
My name is Nikolay. I'm head of platform engineering at HolidayCheck, and in this role I'm now in a hands-off mode and have a bit of time at my hands to think about some of the more esoteric topics of work. As in the recent meetups, I heard people talk about root causes. I thought that it's maybe a good time to remind people, to review the topic again and remind people of something that other people called a couple of years ago the root cause fence. Let's start now with a little story. It is Sunday night, 4 a.m. and you lie in bed and sleep, when suddenly your pager goes off. You get up, find your way to your laptop, log into the company VPN and start debugging. So you find a microservice that is spitting out 500s like crazy, and after a bit more debugging you find an overloaded database cluster. So you scale up the database cluster, wait for the alert to clear, and finally go back to bed. The next day you come into the office, pick up the developers who are responsible for that service and the database, and conduct a blameless postmortem. In this blameless postmortem, you try to figure out what happened. You ask why several times in order to get to the root of the problem. Until finally everybody agrees that a crawler hit your website, created an abnormally high amount of traffic, and that finally overloaded the database. So, satisfied, you close the meeting, you found the root cause. Or did you? Let's see what is actually a root cause. And this definition is a bit of a mouthful, so we will dissect it in the next slides. A root cause is the one sufficient action that triggers a process that eventually leads through linear cause-effect relationships to an event. And the first important term here is one. So it means that the action we are looking for has to be a single action. Something like somebody pushed a button, that kind of thing. It also needs to be sufficient. That means the action must not depend on other conditions like time of the day, phase of the moon. And finally, we must have a linear cause-effect relationship, because the process that connects the trigger with the event needs to always lead to this event. And that is only true if the process is linear and there's a clear cause-effect relationship. So if we have this, then we have a chance of finding a root cause. Unfortunately, reality is not always this nice and tidy as our definition requires. So real systems and processes are often complex networks of interacting nodes instead of linear causal chains. And in networked systems, events are generally not monocausal. So multiple nodes influence each other, we have feedback loops, the network is evolving, connections come and go, nodes come and go, and everything is changing all the time. In these networks, an event Z does not just happen because an action X happened, but because X happened in the context of Y. Had it happened in the context of W, then a different event would have occurred. And in this networked world, we not so much have causes, but instead we have contributing factors. Only together are these contributing factors sufficient to trigger the final event. So let's get back to our story. You believe to have found the incident's root cause in a crawler that sent more requests than anticipated. However, you didn't take some pieces into consideration. So you didn't take into consideration that the database queries that the service sends to the database were not optimized, thereby limiting the capacity more than necessary. Also, the database cluster size was never adapted to real-life traffic, leaving the cluster with much less access capacity than initially designed into the system. Also, the service was badly designed to start with and does not handle database timeouts gracefully. The auto-scaling does not take database capacity into account. It happily spins up new instances when needed, putting ever more pressure on the database. And there are probably other aspects as well that you didn't take into account either. So, what do we take away from this? The takeaway is that there is just no single root cause. Different properties of the system and events conspired to create an incident. We cannot point at any single one of them and give it full responsibility for the incident, which leaves us with the question of what do we do now? If we cannot find the root cause, what can we find? Well, just to start, 5 whys and trying to find a root cause are good if you actually do have simple linear systems. And as Nikolay just said, try to design for them. It very much simplifies your life. And the 5 whys helps you to dig deep into any specific rabbit hole that you identify. However, with contributing factors, we are as much interested in the landscape of rabbit holes as we are in the exploration of any single one of them. We have to search wide and deep. And 5 whys is just a technique to go deep into one rabbit hole and doesn't care too much about all the other rabbit holes that may be there in our landscape. So what we should ask instead is, what else contributed? This is the question that should dominate our postmortems and that will help us identify all the different rabbit holes that are there, waiting for us to fix them. Unfortunately, this question doesn't provide us with an easy answer. It doesn't give us the one single thing to fix and then everything is good. But it does help us to better understand the relationships between things so that we can design a better system. And that is already everything I have to say about it. Thank you. Okay, so Nikolay is asking whether we have regular postmortems. At HolidayCheck, we have rather after-action reports that we write, so we don't gather in a meeting room to do a standard postmortem, but instead we collect the information from different channels, from Slack, from speaking with the people involved, and then write an after-action report. And for that one, we actually try to get the wide information of what happened everywhere and how did the pieces interact. Is there a method similar to 5 whys that would help us to investigate the contributing factors, go to with rather than to depth? And basically that is to not ask why, which just goes deep, but instead ask what else. And this gives you the breadth to figure out what other aspects are there. Yeah, this way you get a much broader view of the whole situation. He is interested in which observability tools technique you use in the after the fact RCA. With regards to observability, we use, obviously we don't do root cause analysis, but we try to figure out which contributing factors conspired. And yeah, we use standard tooling for that. So Prometheus for metrics, Grafana for dashboards. And as we run in Google Cloud, we have Stackdriver for logging and also for things like request tracing.
I can share a little bit. We do post-mortems as meetings, and what helped us really understand also contributing factors during incidents was having a very detailed timeline of what happens. Beginning usually with the first alert that gets into the system, but sometimes even going further before that, because obviously sometimes situations are created or come up before some alert happens. But then what everybody did, what everybody wrote, what we observed, what were the dashboards at certain times, the screenshots, that's also something that we do during the mitigation of an alert already, that we do a lot of screenshots of dashboards. And that really helps to understand an incident situation after the fact.
Yeah, the timeline I also found very helpful to better understand what happened during the incident. But for me, I always found it hard to go beyond the start of the incident. And that's oftentimes where the interesting problems are. Like, as I mentioned in one of the slides, if you have a bad design, that's not something that happens during the incident, but may very well be one of the earliest signs of problems. So using the timeline is certainly helpful, but try to make an effort, I would argue, to go beyond the start of the incident, to also take the environment conditions into account. Okay, so we have another question. We noticed, especially in bigger corporations, that due to the silos, it is very hard to ask the question what else contributed, as you almost never have the possibility to get the complete picture, either due to scale or company silos, and if I have experienced that as well, and what could be done about that besides politics. So far, I've been lucky to work not in the biggest corporations. So at HolidayCheck, which is the largest company I work for so far, has about 450 employees. And this is not a problem. So everybody is open to coming together and trying to find out how an incident happened and what can be done, how to improve the software to prevent the incident from occurring again. Sorry, but I have no experience there. Maybe a question for the audience.
I would like to say something in terms of my impression is it's not always related to the size of the company. Well, Facebook is really, really big, and there is no silos. Like, you have access to a lot of information and a lot of metrics. And I think this is just, well, I don't know what words to use, but design of the company, I guess. Like, having silos at Facebook, it's like super big anti-pattern, and that would be, if something like that happens, it's try to be removed straight away. So, and what you can do about it, to be honest, I don't know. But when I was speaking with different people working in different places, I think this is like CTO level of problem. Like, this is high-level management problem, in my opinion. Silos needs to be removed, and the company needs to work to basically bring everyone together.
All right, then. Thanks a lot also for your participation in the discussion.
Yeah, I'd like to say thank you to both Nikolay and Meetup. See you all at the next meetup.